Okay, I think you'll be able to hear me now. So, I believe you'll be able to hear me now. Unlike the previous one, right now I'm using the tab instead of the laptop, so my audio can be captured. So basically, where we left off from, we finished. Oh no, 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 the camera is how to put it like this. Please, in case by mistake you're not able to say anything, I pray I notice. I want to confirm that the camera, because now I cannot see what is showing us, we have to rely on the time. I finished the time by let me mute this other one, believing that I'll still be able to, like, believing that the audio is still going to be recorded. I believe this is the best I can get. So from this line downward, that's what I'm going to be using. So basically, last live that just ended, I solved this question and we got the three solutions. I asked you to find this one. I don't know if you were reading the comments since I could not talk. I was typing it in the comments, and in the comment I said that okay, you should try out the last one by yourself. But since now you have audio, or I can speak now, since the audio is being recorded, I'm telling you, you can try this one by yourself. The step I did with this one, I spread both sides. By the time I spread both sides, this square here, the square root of cancel, the square root of cancel, and by the time you multiply, you get the difference of two squares. And by the time you simplify, you have a square like you have x minus 1 squared. And since the square root x minus 1 squared, you cancel that square, you cancel out the square root, leaving with just x minus 2. So you will now end up having x plus x, that is 2x, plus 2 times, or what I will get. This book is here. We have x plus x, that is also x, plus 2 times this. That's why it will become difference of two squares. That is x squared minus the square root of 2x minus 1 all squared. By the time you like square root now will cancel out the square, leaving you with just 2x minus 1. The minus now multiply with leaving you with square root of x squared minus 2x plus 1. Because minus times minus is plus. X squared minus 2x plus 1 is already a perfect square. Can I hear myself? Let me confirm. Yes, I can hear myself. Okay, x squared minus 2x plus 1 is already perfect square, and that is x minus 1 squared. And so by the time you have the square root there, the square root cancels the square, leaving you just x minus 1. So you have 2x plus 2 times x minus 1, 2x plus 2x minus 2, that's 4x minus 2 is equal to a squared. The question now says, find the real value of x that makes a equal to square root of 2, 1, and 2. For a equals to square root of 2, we have 2. 4x minus 2 is equal to a square, and square root of 6 a square root of 2, a square is not equal to 2. Move minus 2 to the left right hand side, you have 4x equal to 2 plus 2, that is 4, and that gives you 4x equal to 4. I have a lecture soon by 3 o'clock, so this will have to be fast. By then you divide both sides by 4, you have x equals to 1. So when x equals to 1, a is going to equal to square root of 2, that is the check mark. For the next one is for a equals to 2. When a equals to, I say that I'm not going to plug in a from the beginning of time, because if I plug in a, then for each of the values of a, I have to solve 3 times. Like I have to solve first one for square root of 2, solve again for 2 for 1, and solve again for 2. As I'm not going to go through the last stress, instead I'm going to just solve in terms of a. So by the time I get this simplification, I'll just plug in a. So using that same expression, 4x minus 2 is equal to a squared, I put in a equals to 1, and we get this. But I said you should confirm this by yourself. I'm not going to confirm it. But for the third one, when you put in a equals to 2, you get x equals to 3 over 2. I confirm this also with calculator, and that brings us end of this question. The next question there was another IMO question, but since I'm using tab to record now, I cannot see the question again. So I'm going to search for another question on the laptop to see if we can attempt it in the next few minutes. And don't mind that my clothes is wet. Actually, I don't come out with clothes wet, but sweat and not now for me today. I sweat, and now my clothes is wet. Okay, this is Google. I search for Olympiad type questions on Google, and Google is telling me x squared plus y squared is equal to 2009. Actually, that's actually an Olympiad type of question, and I don't think there's a particular way because they say integral solutions. That won't solve that. I don't think I want to solve that. But if the other number gives us an odd number, then it must be the sum of an odd square and an even square to give us that odd number 2009. So you have to look for an odd square plus an even square that will give 2009. Do I know this? Just look for an odd square and an even square. Try values. The other question here is also m square plus n square is equal to 41. It's the same thing. Just since it's an odd number that is right hand side, then okay, for this one I think I can do it. 36. So 36, 41, 36. Nope, I can't do that in my head. The next one is 25. That is 20. Yeah, 25 plus 16 will work. That is for the next, there's a question here. I don't know if you can see, but there's a question here. M squared plus n squared is equal to 41. 25 and 4 will work. So 5 and 4 will work. That's 5 squared plus 4 squared. That's 25 plus 16, and that is 41. That is the same thing that you do for this x squared plus y squared is equal to 2009. Just look for y. And Google says 1 to the power of x is equal to 4. Well, some people say it's impossible for 1 to the power of x to equal to 4, equal to 1. But that is in the normal real number sense. But by the time you're moving to all this Olympiad, you have imaginary numbers coming out. So yes, you actually have a solution for x that's 1 equal to 4. And do I want to solve that? No, I do not. I'm not going to attempt that. You do that by yourself if you want to learn. None of my business. But me, basically, I just want to look for all those IMO questions that people used to post and like, hey, this type of question. But this one now, 6 power of x plus 6 power of y is equal to 42 and x plus y equal to 3. I did that in the first live stream that none of you watched, but I don't know, I still posting videos, none of you are watching the videos, but who really cares? Somebody that likes doing the maths will have to do the maths. I saw this one. So that. I think basically, I think I've done. Have I done all of them? Since I'm sleeping focused, let me just tell you more. Tomorrow also, that is depends on how much trouble I put myself in for missing classes. But tomorrow also, I may come back here and do 100 level maths test. That's test one and test two, so don't miss it. The just completed test, that is the test that we did last year and like 2 weeks or so ago. That's test one and test two for maths. I won't do it. Then if there's still time, which I don't think they would, but if there's still time, I may go on to do for STA and physics 111 and maybe physics 113. Even though STA was my lowest, but who cares? I'll still do it. Oh no, I can't do for STA again. Okay, this is a question. Most of them here are just pictures of textbook, Olympiad textbooks, and that's not I'm looking for a question. Okay, finally I found the question. The thing says the square root of x plus 7 plus square root of x minus 2 is equal to 9. It's actually easy per se because it's the same thing as we did for this last one. But let's just brush through it quickly. We have square root of x plus 7 plus the square root of x minus 2 is equal to 9. But I square both sides, this square root will count multiply with this square root, like leaving you with another square root. So to cancel that square root, you have to square again. But let's go through that. Yeah. But then you square both sides, you have let's say you have a plus b, and then you square a plus b, you get a square plus 2ab plus b square. Let me write this as a square plus b square plus 2ab. So now a is equal to square root of x plus 7 and b is equal to square root of x minus 2. So we are squaring both sides, we have a square, which is square root of x plus 7 all squared. The square root will cancel out, leaving you with, let me take it back to the live stream so I can make. Okay, it's playing. Okay, so we have, okay now, where was I? Okay, we have a square plus b square is plus 2ab. I told you that a is going to equal square root of x plus 7, b is going to equal square root of x minus 2. So for the first time we have a square root of x plus 7 all square will give you just x plus 7. We have b square root of x minus 2 all square will give you plus x minus 2, plus 2 times the square root of x plus 7 times the square root of x minus 2 is equal to, don't forget, whatever you do to the right hand side for equality, whatever you do to the right hand side, you must also do to the left hand side. So if you square both sides in the left hand side, you must also square both, square both sides. If you square the left hand side, you must also square the right hand side. So 9 squared is going to equal to 81. Let's simplify this. We have 2x, that's x plus x, that's 2, x plus x, that's 2x. 7 minus 2, that is minus, no, plus 5. Plus 2 times the square root of x plus 7 times x minus 2, because square root of a times square root of b, join them together, you have square root of a times b. But don't make the mistake of saying square root of a plus square root of b is equal to square root of a plus b. That is wrong. Only if, I don't know, I'm trying to thinking, but only if some, maybe like when a and b are equal to 0, or when a is equal to 0 and b is equal to b, or when b is equal to 0 and a is equal to a. So one of them is 0, then then square root of a plus square root of b can never equal to square root of a plus b. Okay, since we have that square root of b is equal to square root of ab, then we can write this as square root of x plus 7 times x minus 2 is equal to 81. I told you that some of us are questions are always the same. The more you square both sides, you now collect like terms, then square again. So you collect your like terms. 2x plus 5 is here and 1 is here. Move 2x plus 5 to the left hand side. We have 2 roots x plus 7 times x minus 2 is equal to 81 minus 2x minus 5. 81 minus 5, that is going to be 74. No, 76. That's going to be 76 minus 2x. 76. Yeah, 76 minus 2x is equal to 2 root x plus 7 bracket x minus 2. For simplicity, most of them that, so I think it's the first one that, hey, my abonki has said clean my teacher's marker. Oh no, not teacher, my lecturer's marker. But I think forgive me. You will forgive me. Okay, I mean, this is the first time I actually solve the question that you actually divide by 2. Most times now you reach this part, you have just square and this 2 here will turn to 4 because they're square. But in this case, this all the numbers on the side are almost below 2. Just divide by 2 to make your work easier. By the time you divide by 2, you have the square root of is equal to divided by 2 38 minus x. So you have square root of x plus 7 times. Sorry, you have square root of 38 minus x. Square both sides again, you have x times x minus 2 is equal to 38 minus x all squared. Now I've reached thus far. Let me confirm this place is recording. Recording. I think you are. Okay, it's recording, but I don't think it's clear. But anyways, okay. Anyways, you expand the brackets. Let's expand the brackets inside of the board. You have x plus 7 times x minus 2. Expand the bracket, you have x times x minus 2 plus 7 times x minus 2. X times x down x squared minus 2x plus 7x minus 14. You have x times x is x squared, x times minus 2 is minus 2x, plus 7 times x is plus 7x, and plus 7 times minus 2 is minus 14. For you like, then that is minus 2x plus 7x, that's 5x. You have x squared plus 5x minus 14 is equal to, now all this is equal to 8 minus x all squared. So you have all this is equal to 38 minus x all squared. And 38 minus x all squared is the same thing as 38 minus x times 38 minus x. So we have 38 times 38 minus x times 38 minus x. 38 times 38, I'm definitely not going to use my brain to do that. Or should we? Let's no, we don't attain to temptation. So you have 38 times 38 is 1444. Oh, minus 38x minus 38x plus x squared. Another special thing don't happen. I can say x squared here will cancel the x squared here, so the need was to solve for that equation. So it's very straightforward. So we have 1444 minus 38x minus 38x plus x squared. What do you think we do next? Okay, no, I put it wrong camera. What do you think we do next? Next thing we do is to take the like things. 38 minus 38 minus 38 is going to be equal to minus 72, I think. 38 plus 38. Well, this is like ask capital 1 plus 1. What? I don't have time. Brother, I'm fair. That 144 minus 76x plus x squared. So we have the left hand side is x squared plus 5x minus 14, and right hand side is 1444 minus 76x plus x squared. What do you now do? You equate your left hand side to right hand side. So we have x squared minus x squared plus 5x minus 14 is equal to 1444 minus 76x plus x squared. The next thing you do is to cancel out your x squared, but don't leave it again. Cancel that x squared out. So you have 5x minus 14 is equal to 1444 minus 76x. You take this from minus 76x to the right hand, to left hand side to make it positive, because as a mathematician you hate negative numbers. I don't know why I say that, but just don't like negative numbers. Everything just try to replace stuff with positive numbers, because negative numbers can next time in the exam hall and even at 9 it's 100%. Okay, now you have remove that minus 76x to the left hand side, and you have plus 76x plus 5x plus 76x is equal to 1444 plus 14. Positive numbers, they all love positive numbers. 1444 plus 14 I'm still not going to use my head to do that, so I'm going to use calculator. All through we have 1458, 145, what true? I don't know if that, I think I've heard somebody say that before. Okay, 5x plus 7x plus 76, that is 81x. So now we have 81x is equal to 1458. Next thing you do is divide both sides by 81 because we have 5x, not 81x. So divide both sides by 81. Take it out. 81x is equal to 14. No, I'm at 15. X is equal to 1458 divided by 81. And that is going to equal to 18. Yay! So we have x equals 18. I think in friends that would be like undo, drag, cancel, 6x with. It's going to be a number, just like it's going to be a number. Whatever it is, just that it's going to be a number. 18 is the value of x. Okay, I forgot to check with the board, but I believe I was talking enough. So, yeah, I'm still at this nice show. Going better without me talking because I cannot control my mouth. I talk too much. So, we're just going to talk. Of course. There's no talking. Why was there? Let me just do my body. Oh, where's my body? My body, okay, my body is here. Okay, that's that question. Or should we, let's confirm it. Let's confirm. In everything you do, before you leave an example, waste some time, confirm it, cross-checking. Okay, it's cross-checking, they call it. Cross-check, waste some time to cross-check. What is cross-check? Because we don't know. Okay. So the initial question was square root of x plus 7 plus square root of x minus 2 is equal to 9. But since we are trying to confirm, let's create that 9 and find out what our value will be when x is equal to 18. Okay, let's clean now. Okay, when x equals to 18, we have a square root of 18 plus 7 plus square root of 18 minus 2 is equal to question mark. 18 plus 7. No, I'm not going to pick the calculate this one. Yes, I'm going to pick the calculate this one. 18, no, 25. It's low. Square root of 25 plus square root of 18 minus 2, that is 16, is equal to question mark. Square root of 25, that is going to be 5 plus square root of 16, that is going to be 4, is equal to question mark. 5 plus 4 is going to equal to 6 plus 3, equal to question mark. 6 plus 3 is going to equal to 7 plus 2, equals question mark. 7 plus 2 is equal to 8 plus 1, equals question mark. And 8 plus 1 is equal to 9, is equal to question mark. So all in all, we have our 9 is equal to question mark, x is equal to 18. Yeah. Let's clean that out. I think there's still time to solve one more question. It's meant to be this, so we can come late. I'll just like to tell that I was too far to run. And this one was too hot, so I was walking slowly. But don't lie, flying is not good. So I will go by. I'll just keep the class. The question is here. We have this beautiful question, which but I don't know if this is an Olympiad question, but if Google put it here, we have to solve it. So we have the square root of 9 minus. Oh no, this is going to be easy. But let us try it. Okay, we have square root of 9 minus square root of 8. What will be the value? Now, some people say, oh, I don't know what people say, but some people say things that, why would you have the square root, and that square root is square root of simplified here. So this cannot be simplified to square root of 9 is 3, minus this square root of 8, now you can write it in, I don't know if it's short form or whatever it is, but you can simplify it down to square root of 8 equals square root of 4 times 2. This square root of 4, you can separate it, square root of 4 times square root of 2. And square root of 4 is 2, so this is going to be simply just 2 root 2. The square root of 8 here can be simplified to 2 root 2. Square root of 9 is 3, so you have square root of 3 minus 2 root 2 is equal to question mark. So now, how do you find the square root of a solid? How do you find the square root of a solid? Beautiful question. To find the square root of the solid is like you're looking for a number that when multiplied with itself will give you what's inside the square root. So you're looking for a number that when you square it, you get 3 minus 2 root 2. Like you're looking for the square root of x, right? Square root of x. What you're looking for square root of x, not how to say it. Like you're looking for a number that's like a times a will give you x, that kind of thing. You're looking for a number so that a times a, that's a squared is equal to x. So by the time you square both sides, you now just get a. You get what I mean? So you see the square root of x, you're looking for a number so that a squared is equal to x. By the time you square both sides, you have a is equal to square root of x. That's what we're going to use. And we're going to use a plus b. A plus, okay, in this case, we're going to use a plus, we're going to use a plus b root c. What I'm saying. Let us use a plus root b. A plus root b. So we have a plus root b all squared is going to equal to a squared plus b plus a root plus 2 root ab. No? I'm going to, okay, let's come with this. I'm going to use a plus root b. So that we have to square this, and this will now equal to a times a plus root b plus root b times a plus root b. A times a, that is a squared plus a root b plus b, root b times a, that is a root b again, plus root b times root b, that is going to equal to b. So we have a squared plus b plus 2a root b must equal to this guy inside the bracket. A squared plus b plus 2a root b must equal to 3 minus 2 root 2. Tra minus do root do French. These are not letting me. I'm talking about French. Francophone, francophobic, francophonic. Okay, if I want to compare the two of them, 3 does not have any sword attached to it. So a squared plus b should equal to that 3. And 2a root b must equal to minus 2 root 2. Divide both sides by 2 for the second equation, and we have a root b is equal to minus root 2. Simple like that. Now from the first, now we have two systems. I think system of equation they call it. We have a squared plus b is equal to 3, and we have a root b is equal to minus root 2. So for the first expression, let's call this equation 1 and equation 2. Equation 1 and equation 2. For equation 1, we have that a squared must equal to 3 minus b. A squared must equal to 3 minus b. A squared must equal to 3 minus b. So square root of a. A will now equal to square root of 3 minus b. I go again. We have a squared plus b. By the time we compare a squared plus b plus 2a root b with 3 minus 2 root 2, we have that a squared plus b must equal to 3, and 2a root b must equal to minus 2 root 2. If we divide both sides by 2, we have a root b is equal to minus root 2. From a squared plus b is equal to 3, we will get that a squared is equal to 3 minus b, and a is equal to the square root of 3 minus b. Now, if we attach these two equations, that is a is equal to square root of 3 minus b, and a root b is equal to minus root 2, we will get that the square root of 3 minus b times the square root of b is equal to minus root 2. Okay. From the first thing I said at the beginning of the live stream, I said that by the time you have square root of a number times square root of another number, you can merge them together. And you have the square root of, that is 1b square root of 3 minus b times b is equal to minus root 2. Now what do you do to cancel out the square root? You square both sides. And then you square both sides, you have 3 minus b times b is equal to 2. Minus root 2 all squared is going to still give you 2. It's not going to give you minus 2, it's going to equal to 2. Okay. If we expand this bracket on the left hand side, you have 3b minus b squared is equal to 2. Move everything from left hand side to right hand side, and you have b squared minus 3b plus 2 is equal to 0. Let me go to this side of the board. we have b squared minus 3b plus 2 is equal to 0. If you minus 2 from both sides, we have b squared minus 3b is equal to minus 2. If you complete the square, you will get, you have to add 9 over 4 to both sides. You have b squared minus 3b plus 9 over 4 is equal to minus 2 plus 9 over 4. The left side can be simplified to b minus 3 over 2 all squared is equal to over 4 plus 9 over 4 minus 8 is simply just 1 over 4. If you have b minus 3 over 2 is equal to 1 over 2 plus minus 1 over 2. And that's because 1 over 2 all squared is equal to 1 over 4. So square root of 1 over 4 will give you 1 over 2. So b is equal to 3 over 2 plus minus 1 over 2. For the plus, you have 3 over 2 plus 1 over 2, that is 2. And for the minus, you have 3 over 2 minus 1. So we can take the numbers 2 or 1. So now that we're working what the two possible values of 3 minus b. If b is equal to 2, then a is equal to 1. That is because 3 minus 2 is going to equal to 1, and square root of 1 is 1. But if b is equal to 1, then a is going to equal to the square root of 2. That is, if b is equal to 1, then a is equal to square root of 3 minus 1, and a is going to equal to square root of 2, because 3 minus 1 is 2. So these are all two sides. A comma b, or bracket open a comma b, is equal to bracket open when a is 1, b is 2, or when a is root 2, b is 1. So 1 comma, try and divide or like the square root of 2 root 2, which we are set to find out from the beginning. We have to complete it as a plus root b. That is, because a plus root b that will give us the square root of. If a is equal to 1 and b is equal to 2, then we have 1 plus root 2 as our first solution. And for the second one, when a is equal to root 2 and b is equal to 1, we have root 2 plus 1. So there is only one solution. So we have 1 plus root 2 twice. That's basically, most of them come out in that form, but you just have to just try it, because you will not know when you have two different solutions. But in this case, we have one solution. So the square root of 3 minus 2 root 2 must give us 1 plus root 2. And as always, as I said, you have to always confirm with your cashew, because cashew was there to cashew. Cashew was there to cashew. I don't know what around cashew, but cashew was there to give you cashew. So your shoe will be black. That 3 minus 2, and that is equal to calculator gave me decimal point. Well, anyways, let me write it down. The calculator says 0.41421356624. What is this? Okay. And for the second part, we have 1 minus root 2. And in this case, the calculator now give me in also in decimal points. It doesn't give me like just root there as 1 minus root 2, but if you press this S arrow D, it change it to decimal point for you. And that is 0.141421356 and 4. 0.141421356 and 4. Oh, that's feeling. And that confirms it. So I believe my messy board, you can understand what's there. I'm going to confirm how long this has been going on. Okay, it was 7 minutes. I'll do some more. Come, let me share this thing. Okay, this next question asks us, can you solve x equals to the square root of 5? I mean, the question is long, but you can see the question by yourself. You have x equals to the square root of 5 plus root 99 divided by 2 plus square root of 5 minus root 99 divided by 2. Ah, clear your sweat. I'll go again. Okay. Inverted. It was a very bad idea to have shifted this camera because now I don't know how to adjust the back. Blah, 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 blah. No. Okay. The is not as clear as before, but I think the internet reduced, or I think whatever speed or whatever the computer will call it, but I think the speed of the internet reduced. The feedback is not as clear as before. I'm coming. I'm just waiting to stabilize back. But I think it's just going to be from laptop's end. I don't think all the videos will be blurred like this. It's just going to be from laptop's end. But anyways, okay, we have x equals to square root of 5 plus square root of 9. So we have x equals square root of 5 plus square root of 99 over 2 plus square root of 5 minus square root of 99 over 2. What's the value of x? The way the quick construction, I feel like you can put inside your calculator and to give you maybe a decimal form like that one, which I actually don't like, or it will actually give you in short form, which I'm not 100% sure if to give you in the decimal point or the short form. But I feel like the people that made this question would not want the people that are solving it to use calculator. So I'm going to attempt, guys, except if I'm seeing 99 squared, then I have to go back to calculator. But if there's no 99 squared, every that now I'm just going to try and attempt it without the use of the calculator. Okay, this is our questions, right? To solve them, you don't really need to start looking for a way to add two square roots. Because I don't think there's any way to add two square roots. So instead, what I'm going to do now is to square both sides, then square root both sides. Like, we have x equals to all these numbers. If I square both sides, this can be simplified. Then by the time I square root, I feel like the numbers will be better off than the way it's looking now. So x squared is equal to the square root of 5 plus root 99 over 2 plus square root of 5 minus root 99 over 2 all squared. The same like in the last video, we have a squared plus b squared plus 2ab. This last video, the last two videos, we have a squared plus b squared plus 2ab. A is equal to square root of 5 plus root 99 over 2, and b is equal to square root of 5 minus root 99 over 2. So a squared is going to be equal to 5 plus root 99 over 2, and b squared is equal to 5 minus root 99 over 2. Don't forget plus 2 times root 90 root 5 sorry times 2 plus 2 times root 5 plus root 99 over 2, that is the value of a, and b is root 5 minus root 99 over 2. Root 99 over 2 we cancel out with minus root 9 over 2, leaving you with 10. That's 5 plus 5 is 10, plus 2 times. Now this thing here, as I said, if you have square root of a and square root of b multiply each other, you can, like, if you have square root of a times square root of b, you can just merge them together as square root of a times b. So this will be 2 times root 5 plus root 99 over 2 times 5 minus root 99 over 2. And just like the other questions also, you have two numbers of times and they are like conjugates to each other. 5 plus root 99 over 2 and 5 minus root 99 over 2. You can also use the difference of two squares as 5 squared minus root 99 over 2 all squared. Okay, you know 99 squared like here, square of 99 all squared, so square of cancel square, so I still don't need to calculate here. So we have square root of 5 squared minus root 99 over 2 all squared. Don't forget the remaining part of the equation. The remaining part of the equation, we have 10 plus 2 root n. So simplify that further again, we have 10 plus 2 root 5 squared is 25. Root 99 over 2 all squared is going to be 99, and this 2 squared will be 4. So we have 10 plus 2 root. Let me write this down. 99 over 4. So we have 10 plus 2 root. This 25 can be written as 100 over 4 because 25 is only we have the same denominator. Because if you have the same denominator, you will not be able to add them easily. So always have the same denominator. Or either you have made them have the same denominator, or you change this 99 over 4 to fraction. Sorry, to decimal point. I don't change decimal point. I don't change them to fraction. So just in case we have this square root. Because if I change it, let's say I change 1 over 4 to fraction, and I'll have 0.25. If I want to square 0.25, like if I don't know it was 0.5, I'll change that 0.25 back to decimal points, back to fraction before I square root. Because it's better to square root whole numbers for me than to start square rooting fractions. Start square rooting decimal points. So we have 25 equal to 100 divided by 4 minus 99 divided by 4. 100 minus 99 is going to be 1, so this is 10 plus 2 root 1 over 4. 1 over 4, square root of 1 over 5, I say it's better to square root 1 over 4 than square root 0.25. The square root of 1 over 4 is just going to be square root of, so it's going to be 1 divided by square root of 4, which is 1 over 2. We have 2 times 1 over 2. The 2 here will count to 2 here, leaving with just 1, so this is going to be 10 plus 1, which is equal to 11. Don't forget that this is not the value of x, so we square both sides, we have to square it again. So this is x squared is equal to 11, so x is equal to the square root of 11. That means if x is equal to the square root of 5 plus square root of 99 over 2 plus square root of 5 minus square root of 99 over 2, it all simplifies down to square root of 11. And as I always say, you have to trust, well, I don't use the word that you have to trust your calculator more than your brain, but it is what it is. Square root of 5 plus square root of 99 over 2 plus square root of 5 minus square root of 99 over 2. Okay, he gave us a decimal point, but let me write it out. The decimal point is 3 points. I don't know, normally the class always give me like if it's square root of 11, it always states as square root of 11. But these two questions now, they have given me a decimal point, and it's not pretty. That pretty things. All the number of decimal points. Decimal points. I hate negatives. I hate imaginary numbers. But you need them. You need them in maths. That's painful. Okay. Now the next one is to confirm for square root of 11. And square root of 11 is, you can see square root of 11 as I type square root of 11. If you just really get square root of 11, you not put in decimal point. When I put this up one, you use the decimal point. So I feel like it's on all this approximation. Like you round this calculator, I don't think it have infinite amount of digits. At the point in time to stop and just round up. I think maybe 16th digit to stop, like the 16th decimal place, it just stop and just round up. So that around, I feel like that's what like change the value you need to. But let's just put it as decimal point. But because all I just want to look at this 1, 2, 3, 4, 5, 6, 7, 8. All I just want to look at the 18 decimal place. So sorry, did I say 18? All I just want to look at, I just want to look at the 8th decimal place. So us will not see that difference. But maybe the computer will see that small slight difference at maybe the 16th decimal place and be like, okay, this number is not the same, even though it is them themselves that, even though it's calculated itself that rounded up. So our square root of 11 is also going to equal to 3.3166247 Let's go again. 3.3166247 Same number. So x is simplified to square root of 11. That's basically it. But the question itself asks us what's the value of x. And for me, I feel like, should that be a correct way of putting the question? Shouldn't it be simplify, then put this here? Because you're asking me what's the value of x. This is the value of x. This is square root of 9, square root of 5 plus square root of 9. But so this expression is already a value of x. So I feel like the question should have asked, like, simplify this here. Then I will now walk down to getting square root of 11. But this is basically what they mean. I believe that's basically what they mean by what's the value of x. Even though they give us the value of x. Okay. 6 more minutes for the next class. I will just solve one last one, then call it an afternoon. This is the last question I put here. The last question I solved. And all the things I go with, most of the things I go with bringing out is all they are all textbooks I'm seeing here. That's Olympia textbooks, not question. There's a question I had in my head that I wanted to solve before the last live. Let me see if I can remember it. Okay, I think we have like 21. I think this is like the first Olympia question that I solved myself. Other ones that they are hard. This was the first. Okay, we have 21n plus 4 and divided by 14n plus 3. That we should prove that this is irreducible. That is, you cannot reduce this. Like, if you divide whatever the value of n is, if you divide this, you will not get a whole number. That's right. When n equals to 1, you have 25 divided by 14. 14 plus 3 is 17. Irreducible. There is not can cancel again. 25, no, there's nothing that can cancel for 25 and 17. But 17 is the prime number. So there's nothing that can cancel out 25 and 17. Let's check for n equals to 2. We have, I'm not sure this is the correct question, but it's something in this sense. Just in case the thing cancels out. Just like, I don't think this is the correct question, but it's something in this. Like, okay, when n equals to 2, we have 42 plus 4 divided by 24 plus 3. 42 plus 4, that is 46, divided by 24 plus 3, that is 27. 27 is a multiple of only a multiple of 9, and 3, that is 3 power of 3. And 46 is not a multiple of 3, so it's still irreducible. This is in the lowest term. But I'm still not going to solve this yet until I confirm that this is the correct question. Let me keep searching. there's a question I'm saying here. This is like I've searched. This is the only question I'm saying here, and it's the number 11466600 can be written as the product of two factors in how many ways? That's all. Can be written as product of two factors in how many ways? Oh, that would be loads. That's how many am I solve that one? But that is Olympiad and NTSE type questions. Definitely going to Mr. I was Mr. Bala allowed me stay. Mr. Bala allowed me stay for live stream. Live stream. Yes, mass. I still can't find the question. I just saw it today. I saw it today. Okay, I searched it. I put this one that I believe it was in Google and confirmed that it's supposed to be city. And IMO question. Um, so that's actually the correct question. Who is the fraction of 21n plus 4 divided by 40n plus 3 is irreducible for every n in the natural number? And somebody said anybody can do this. Wow. So that means the first one I tried doing, everybody could do it. But basically, the idea that I used was that GCD of two numbers, like GCD of 21n plus 4 and 14n plus 3 must equal to 1. That is the greatest common divisor or divisor, I don't know the pronunciation, but the GCD of 21n plus 4 and 14n plus 3 must equal to 1. Just like the distance, just for 4 and 3. Now, for an example, it's already in 0 So the greatest common divisor is if you write 4 and 3 in their factors, the factor of 4 is I think 1, I think it. The factor of 4 is 1, 2, and 4, and the factor of 3 is 1 and 3. So the greatest common divisor here is 1. So it's only 1. But let's change the number from 4 to 4 and 3 to maybe 4 and 6. 4 and 6. For 4 now you have 1, 2, and 4, and for 6 you have 1, 2, 3, and 6. In this case now, there's one person in two of them, but there's also two present in two numbers. So 2 will be the greatest common divisor of 4 and 6. So by the time you divide, just like by the time you divide 4 and 6, you have something that will cancel out. That's just the idea of it. You have something that will cancel out in 4 and 6. So the proof that I like to prove is that no matter what value you have, by the time you divide 41n plus 4 with 14n plus 3, you would have like it will be its lowest term. Another thing you can also another idea you can have like this is that there must be a remainder. Like if they are in the lowest term, there must always like be a remainder. Okay, let's look at an example. That's 4 and 3. 4 divided by 3 now you have 1 remainder 1. There must always be a remainder in the number. Nothing will cancel out. Okay. Common divisor of 21n plus 4 and 14n plus 3 will equal to the GCD of 21n plus 4. No, let's change it. 7n minus 1. No, plus 1. That is, I subtracted 14n plus 3 from 21n plus 4. In the sense that if you have this now, you can write this as 14n plus 3 plus 7n plus 1. That is 14n plus 3 plus 7n plus 1 is the same as 21n plus 4 divided by 14n plus 3. This now can cancel out to 1 plus 7n plus 1 divided by 14n plus 3. If you multiply up and down by 2, you have 1 plus 1 over 2 times 14n plus 2 divided by 14n plus 3. This will leave you with 1 plus 1 over 2 times 14n plus 3 minus 1 divided by 14n plus 3. This will leave you with 1 plus 1 over 2 times 1 minus 1 over 14n plus 3. You can see that no matter what value of n is, from the smallest natural number. The smallest some people say the smallest natural number is 0 or 1. So let us start from 0 to settle everybody's case. Even if you say natural number start from 0, you say natural number start from 1. Let's just start with from 0. So from here now you have that you have 1 divided by 14n plus 3 as like the final remainder of everything. If you put in n equals 0 here, you will still be left with 1 over 3. So this other number that is 21n plus 4 and 14n plus 3 is going to be in its lowest term. Let's now put in n equals to 1. You have 14 plus 3. But you know what gets bigger. 14 plus 3 is going to be 17. 1 divided by 17 already is lowest term. Put n equals to 2 there, you have 28 plus 3. 28 plus 3 that's 31. 31 2. 31 1 over 10. 31 is in its lowest term. Put in any number you want. As long as you have 1 divided by another number x. This number will be divisible. If it was 2, okay, we'll find a way, maybe have a number here that will be cancelled. But if it's 1 like that numerator, no matter what value you want to put on, 1 is already in its lowest term, so 1 will not cancel out. What won't cancel out with? So that's basically my idea of the proof that 21n plus 4 divided by 14n plus 3 will always give you like a number in its most reduced form. Basically, yeah. We'll solve this last one. I think I said last one was this one was 1 more. Okay, we have the square root of a plus the square root of minus a is equal to 12. We should find what a is, find the value of a. Looking at the question, I 100% believe that they have to be the imaginary number hiding somewhere. Imaginary number must be like I feel like a would have to give us an imaginary number because we have square root of minus a. If a is a negative number the square root of a would give us an imaginary number. If a was a positive number, the square root of minus a would give us an imaginary number. So it's only if a equals to 0. And in that case, you have if a equals to 0, then the left hand side equals to 0 and the right hand side equals to 12. So I believe this number will have that a must be an imaginary number. But to solve this, we have to square both sides. As I said, whenever you have a number in this term of square root of x plus square root of y is equal to another number, to cancel out square, just square both sides, then simplify, then square both sides again. So square both sides, you have square root of a plus square root of minus a times square root of a plus square root of minus a is equal to 12 squared, and 12 squared is equal to 144. If you square both sides, you have square root of a times square root of a plus square root of minus a plus square root of minus a times square root of a plus square root of minus a is equal to 144. Square root of a times square root of a is equal to a plus square root of a times square root of negative a equals square root of minus a squared. And this square root of minus a squared can be simplified to ai, or let's just do that as a squared. Let's just do that square root of minus a squared. But as you can already simplify to ai, that's a times the imaginary number. But let's just do that square root of minus a squared for now. So we have plus square root of minus a times square root of a will still be with square root of minus a squared plus square root of minus a times square root of minus a will be with minus a. Now, some people say we see that the square root of minus a times square root of minus a will equal to a, because they are thinking that okay, maybe we have square root of minus a times square root of minus a. Because I said like if you have square root of a times square root of b, you can just merge those two things inside. You now say minus a times minus a is now equal to square root of minus a times minus a, that is a squared, and then you now do just get a. Oh no. When they are dealing with imaginary numbers, this square root of minus a squared will equal to a times I times a times I. A times a will equal to a squared, and I times I is minus 1. I times I is not plus 1. I times where is the, I mean, LT. I'm coming. Somebody sent me a message that where am I? I think they're calling for class, but I'll go later. Okay. We have, so now that just shows you that I squared is minus 1. I squared is not going to give you plus 1. So even if you have a square root of a times square root of, so if you have a square root of minus a times square root of minus a, it's not going to give you just a, it's going to give you minus a. It's equal to 144. A will cancel out minus a here, leaving with 2 root minus a squared is equal to 144. Divide both sides by 2, you have square root of minus a squared is equal to 72. Square both sides, you have minus a squared is equal to 72 all squared. Divide both sides by minus 2, you have a squared is equal to minus 72 all squared. Square both sides, you have a is equal to 72 root minus 1. And root minus 1 is I, so a is going to equal to 72i. So 72i, so then the square root of 72i plus the square root of minus 72i will equal to 12. Unfortunately for us, Cash will not handle square root of negative numbers. But let me try. Yeah, math error. But so you know that square root of negative numbers exist as I. But let me try with I. Let me put I. I is not going to happen. So Cash will not help us confirm this one. Or wait, there's complex number here. Okay, there's complex number here. Square root of minus 1. Yes, there's complex number here. Square root of minus 1 will equal to I. Let's try it out. We have the square root of 72i plus the square root of minus, we don't even accept square root of negative imaginary numbers. No. So there's no way to prove it the Cash rule, because the Cash rule does not accept square root of negative imaginary numbers. You can have square root of negative numbers like square root of minus 1 and tell you I. But you have square root of negative I. Like here you have to have square root of negative 72i. You cannot accept it. So you can't actually prove it with calculator. But I think I have Which one? One or two? Come to the answer is there. Okay. I thought it was come for this live stream. Hi. And I'm almost over. I mean, maths department. I think maths department is even closed. I'll go and meet you. I'm coming to meet you now. Yeah, I think it's come for this thing. I totally forgot. Okay. I'm still looking for a way to, prove it to you guys, but there's no way. Okay, I said I want to ask Gemini to confirm the solution. Because I always like confirming the solution in order not to make a mistake. The square root of a plus the square root of negative a is equal to 12. Okay. This was their solution, the exact same thing. The first thing, step one, you wrote down the question. Step two, you spread both sides. And you can see here, they said a plus the same thing we did here. But here they put minus a instead of plus a. I told you that if you're having the square root of negative a times square root of negative a, it does not turn to a. Even though minus a times minus a is a squared, it still does not turn to a. You have to put it in the form of imaginary number. Square root of negative a is equal to square root of a times I. That is, I is the imaginary unit. Square root of a times I. So square root of a times I times square root of a times I. Square root of a times square root of a. You can do that as positive number, sorry. You can do that as real number, sorry. So you can just multiply them normally as a. But I times I will be minus 1. So square root of negative a times square root of negative a will be minus a and not just plus a. And that's what they did here. The next thing, a and a will cancel out. So divide by both sides by 2. And they got square root of minus a squared is equal to 72. Then now they square both sides. That is 72. They wrote it here as 5184. But I didn't square both sides. So the final answer was a squared is equal to minus 5184. But if you still express that, okay, let's go to the calculator now. If you still express that as square root of minus 5184, okay, now the calculator can help us prove this. You have 72i. But Gemini did not finish solution. They only say that solution A is not inside the real numbers. But what if I wanted my A inside the real numbers? Let me add it there in complex number. That's what I find that A is not inside the square, it's not inside the real numbers, but let me add it in complex number. Because what if you want your numbers in the imaginary parts? Like, what if you accept imaginary, what if you accept complex numbers, not just in the real hand? The solution, okay, I missed the point. Then I say A is equal to plus minus 72i equals plus I and plus 72i and minus 72i. For me, I only did the positive square root. But they're right actually. They're right. It's supposed to be the plus and negative square root. So that's basically the same thing. The solution was plus 72i and minus 72i. What's really good? Positive 72i. And their negative 72i came out from the fact that if you square both sides, as I square rooting, that plus minus will show, but I didn't reason that far. I just put it there as only the plus 72i because who really wants negative numbers inside the imaginary number? You already have imaginary number, you now still want another negative number again, so I just omitted that negative one. But yeah, it's still meant part of the solution. And that is wow. Well, that brings us to the end of this year of nonsense. I mean, this today of full nonsense. Even though I know that I'm talking to myself because nobody joined the live stream, but I'm just wasting my time on this YouTube. I'm not going to blow, but I still keep doing it because I'm bored. It's boring. So you always smile and get smile that because as I smile to the camera, I'm not watching the video from my laptop, so I'm seeing myself smile back. So it's like ah, I don't know. It's like I just need views. So that's ah. Let me drink some water. Wait. But possibly, I believe, even though I know stuff, let me check. Yeah, I think okay, I'm still the only person that is in the live stream. Okay, but even though I know I'm stuck to myself, but possibly I believe oh no no. Okay, somebody yes, someone participated though. Mindset on fire 24. Someone participated. Oh my god. Yes. I thought only my dad that won't participate in this thing, but somebody else participated. Mindset on fire. Nice, thank you. I don't know how do I reply. Well, I guess there's one viewer, like something that I don't meet would eat all the burger today because of this. One viewer that is I'll celebrate it burger. We all eat one piece of akara and one piece of bread. That is the Saban diet. I mean the Lord's diet. Ah, but because of this comment, enjoy. Let's talk one more. Let me just confirm first if Emmy class is holding. Yeah, just let me just confirm if Emmy class is holding. But if it's not holding, then we'll solve one more question since at least there's a viewer. Okay, I don't know how to reply. Okay, I've sent a question to reply. Thank you. Thank you so much. Oops. Nice. Mindset on fire. Mindset on fire. That means what's born of pictures. I don't have any picture in my family. I told my dad. I know my dad's YouTube name. So it's not going to be him, I believe. I pray. Because I want other viewers. I pray all my classmates. Oh no, that one of my classmates. Anybody I beg, whoever it is, thank you for watching my live stream. And it just give me joy because now that you have shown me that people are watching, I'll do more. I'm not listening when they tell me that I stop. Keep doing it. Because how you stop solving maths? So if I stop solving maths, like stopping drink water, that's not good. Ah, you have drink. Okay, we still another question. This question is quite elementary correct English. I don't know. But it's quite simple. Let's bisect it like Nigerian players. Bisect it the way this bisect this people's leg. Give them OC and score goal. So we have the square root of 3 minus 1 divided by the square root of 3 plus 1. So if I form a lecturer, it will be boring and hard. So you have to do every day. Hello. This is the child office. I met him too. I know it's the lecturer office. But who's there? He used to be. Oh. Okay, so we have the square root of 3 minus 1 divided by square root of 3 plus 1. And they say we should rewrite it in the form of a plus b root 3. So basically, we have to rationalize this. Rationalizing, I don't know. Let me put my camera back so I can see my face. Okay, so rationalize this now. You know your conjugate. But let's just start from the basics. I don't think I've ever taught before, but let's start from teaching. This was just solving. Let's teach this. I'm teaching this because actually this is what we're doing now in our 100 level. That is, it's not going to be square. It's not going to be source form. It's actually imaginary number. That is, instead of this square root of 3, maybe they'll put 3i. But basically the same concept between the two of them. Both rationalizing and solving of like the fraction of two complex numbers. Basically just the same idea. So that instead of having square root here, you're having having the imaginary number. So it's just the same thing. But so I'm not going to explain it from the beginning. So you get the idea of conjugate. The conjugate of a plus. In fact, conjugate is not really there's no calculation behind it. It's just you see that positive number, that positive sign here, remove it, put negative number, put minus there. If you have minus there, remove that minus, put plus there. There's no much thing inside conjugate. So the conjugate of root 3 plus 1 will be root 3 minus 1. The conjugate, in fact, I think the only math behind conjugate is what number will you multiply with another number that will give you difference of two squares. I think that's like the only idea behind this conjugate thing. Because if you multiply a conjugate by itself, you have difference of two squares. So if you have something like a plus b multiplying with its conjugate, which is a minus b, you would have a squared minus b squared. So I think that's only math behind that. What number would you multiply with itself? What number will you multiply? Not with itself. What number will you multiply with another number that will give you the difference of two squares, and that will be the conjugate of that second number or that number. Just conjugate it down. The conjugate of a is b, and the conjugate of b will be a. That is conjugate of a plus b is going to be a minus b, and the conjugate of a minus b will be a plus b. Okay. This is why I was back to the idea of conjugates. Let's go on solving this. Now to solve this, since we know that this thing, if I multiply two conjugates by two, since we know when I multiply two conjugates together, we will get difference of two squares, and we have the square root here that won't cancel out. We have to multiply the square root of 3 plus 1 by the square root of 3 minus 1, and because of the fact that if you multiply by something, you have to still balance it out. That is, if you have left hand side and right hand side, if you multiply the left hand side by 2, you have to multiply the right hand side by 2. But since now we have only just a fraction, if you multiply the numerator by 2, you have to multiply the numerator by 2 for balance. So since we multiply the numerator by the square root of 3 minus 1, you have to also multiply the numerator by the square root of 3 minus 1. So now if you are multiplying the numerator here, multiply the numerator here, giving you square root of 3 minus 1 all squared, and the denominator here will multiply the numerator here, giving you square root, I know difference of two squares. So you have square root of 3 all squared, which is just simply 3, minus 1 squared, which is simply just 1. Is equal to square root of 3 minus 1 all squared divided by 2. Simple. It's like counting numbers with your toes. Counting numbers with your toes. Simple like that. So yeah, you have square root of 3 minus 1 all squared. Square root of 3 minus 1 all squared, same way you have been multiplying all your brackets. You expand this bracket the same way. You have 3 minus 2 root 3 plus 1. 3 plus 1 is 4. Sorry, divided by 2. All divided by 2. 3 plus 1 is 4 minus 2 root 3 divided by 2. If you have 4 minus 2 root 3 divided by 2, just divide all through by 2. And you have 2 minus root 3. So now if you compare with the first one, you say you should put in the form of a plus b root 3. If you compare, a is going to equal to 2 and b is going to equal to minus 1. But let me confirm something. I don't know if it said a plus b. Yes, it's a plus b root 3. I thought because a minus b root 3 that they say, then b is going to equal to minus. No, then b is going to equal to 1 because that is where you have the minus there. But since a plus b root 3, then b is going to equal to minus 1. So the minus will now come up in the question, in the solution. So a is equal to 2 and b is equal to minus 1. Let's do one more. Oh, where's Jimmy's name? Wait, I just got his name. Okay, I'll meet him later. We do one more. Yes, let's do one more. Any other viewer? No other viewer. Okay, only one watching. Shame on me. 102 seconds ago. Started streaming. 102 seconds ago. 102 seconds ago. 102 seconds ago. How come it's 2 minutes that's showing there? Okay, yeah, 1 hour. Okay, 2 viewers. Yay! Yippee. Okay, no, actually 1 viewer because I'm mostly viewing myself. So, hello, 1 viewer. Yippee. Okay, let's look for one more question to dissect. See this question. Okay, this question says that the square root of a plus b is equal to 7 and a plus the square root of b is equal to 11. Now, I've not seen this type of question before, but I believe I'm still going to be able to find a way to handle this. Okay, just look at it for some time. Okay, let's do something. If we square the second equation, we would have a squared plus 2a plus b is equal to 121. So that is a squared plus b plus 2a plus b is equal to 121. B is here, A is here. Okay. Okay. We have this b here and we have root b here. I want to look for a way back to remove this b from here and remove this root b from here. So I'll have the whole expression in terms of a. I have the whole expression in terms of a. I can now solve for what a would be. So b is here, and from here we have that b is equal to 7 minus root a. We have that b is equal to 7 minus root a from here. Okay. And from root b, we know that root b is equal to 11 minus a. So let's put all this information back inside here. So that is a squared plus b is 11 minus no, b is 7 minus root a plus 2a root b now is 11 minus a is equal to 121. So that is a squared plus 7 minus root a plus 22a minus 2a squared is equal to 121. Let me confirm a squared plus 7 minus root a plus 22a minus 2a squared is equal to 121. 7 plus, going to move 7 to the left hand side, we have a squared minus root a plus 22a minus 2. Okay, no, minus 2 squared, we can cancel out 1 a squared there. That is minus a squared minus root a plus 22a is equal to 121 minus 7. That's 114. 114. That is minus a squared minus root a plus 22a is equal to 114. Move all these guys to the right hand side. We have a squared plus root a minus 22a is equal to 1 no plus 114 is equal to 0. If we let a equal to x squared, then this will be a x to the power of 4 plus x minus 22 x squared plus 114 is equal to 0. So I like to solve this quintic, I think quintic, right? Cubic is for power of 3. So power of 4. Quartic, I think quartic. But I like to solve this quartic expression. And some of this quartic expression is going to be hard, but we thank God for the use of calculator that we're not allowed to use, so don't use calculator. Ah. Okay, so whenever you have some problem, the first 6 numbers you try is -3, -2, -1, 1, 2, and 3. That is, if you are not giving a quadratic equation, like quadratic expression to solve, let's try these 6 numbers. If it's not part of these 6 numbers, then just give one solution. Give one because even this thing even cubic, is it cubic? You want power of 3, even cubic expression, cubic equation, the formula for cubic equation is large. So just whenever I try -1, -2, -3, +1, +2, +3, and it's not there, just give up. But okay, let's try for +3. Let's try for +3. So that will be x minus 3 divided by or divided with x power of 4 plus x minus 22x squared plus 114. X power of 4 divided by x, that's x cubed. X cubed times x, that will be x power of 4 minus 3x cubed. If we subtract, we have 0 and we have plus 3x cubed minus 22x squared plus x plus 114. 3x cubed divided by x, we have plus 3x squared. 3x squared times x, that will be plus 3x cubed minus 9x squared. Subtract again and you have 9 minus 22 minus 13. And you have minus 13x squared plus x plus 114. Minus 13x squared divided by x, you have minus 13x. Minus 13x times x, you have minus 13x squared plus 39x. Okay? Subtract again and you have 0. 39x, or 1 minus 39 will give you minus 38. That's minus 38x plus 114. Minus 38x divided by x, you have minus 38 And 38 times x, you have minus 38x plus 114. Minus 38x plus 114 minus 38x plus 114 will give you 0. So x minus 3 is a factor of x power 4 plus x minus 22x squared plus 114. So x must equal to 3. But x is not what we're looking for. We have to find value for a and b. A and b. Yes, a and b. We have to find value for a and b. And we know that x is directly linked to a. Consider that a is equal to x squared. If x is equal to 3, that means a is equal to 3 squared and a is equal to 9. So we know that a is going to give us 9. But now that we know what a is going to be, you can put in a equals 9 into any of these expressions. You can put a equals 9 into square root of a plus b is equal to 7, or a plus square root of b is equal to 11. Let's pick the first one. We have square root of a plus b is equal to 7. Square root of 9 is 3 plus b is equal to 7. So b is equal to 7 minus 3, b is equal to 4. So we have a comma b as is equal to a is 9 when b is 4. Now this is the value for a equals 9. So I'm sure, I believe 100% sure that if I put in this a equals 9 into the second expression, I'm supposed to get the same result. So if I put a equals 9 into the second expression, we have 9 plus square root of b is equal to 11. Square root of b is equal to 11 minus 9. Square root of b is equal to 2. And b is equal to 4. That is b is equal to 2 squared, which is 4. So that has it. A comma b is equal to 9 comma 4. Or b is equal to 4. No, not when a equals. I don't think that's the correct language to use. The correct language to use is solution for a and b is 9 and 4. I think. Because I feel like you have to use that when a equals to 9, b equals to 4 is when like there are two solutions, I think. Okay, Jameson, come to Migo Mobile. What's Migo Mobile? Okay, MA class no holding, so I can still stay here till. Okay, MA class no holding, then I can start solving the this thing what they call it 200 level question now. Okay, but this should come to Migo Mobile. What is that? Solve and proof. So since MA class is not holding, I will end this stream. I want to get this one question, then continue another stream. That will be the correct thumbnail. Right? This thumbnail is for this stream, so I don't actually think it twice. I just put a picture of me smiling. But I will end this stream and start a new one with the correct thumbnail that I created for the other live stream. So, bye bye. How do we end this stream, sir? just